Cool. I'm Brian Corteil. I'm a compulsive maker and I also enjoy making robots. I don't know if you've seen it, but in the main area, I was doing the microphone now. So, as I said, at the last event, I built Revenge, and it was my entry for Pi Wars, and done really well, passed my expectations, and actually won the A3 character. And I thought with the new Pi Wars coming up, that I would share some tips on how to build a robot. So, let's go. It's only 198 days to build a robot. The next Pi Wars. No need to panic, plenty of time. So, as I said, it's talking about things that going crazy. So, this is Revenge, my robot, and it's doing what he likes doing as well, is actually driving up stupid slopes outside. So it's a 6-wheel drive robot. It's powered by the type of lithium battery that makes the life interesting if you use it incorrectly. 6-wheel drive and has a Pi-Wall Delelo controller. The motors are 12 volt and 300 RPM. And as you can see, it makes it a very capable basic chassis. So the most important part about your robot, and I've got to really say this, is actually your chassis. First thing you do is that you build a good chassis, put your motors on it, and then you drive it. So I don't think I'm jumping myself to things. So some of the choices of steps: what type of robot you're going to do, what configuration it's going to have. It's in front of me, isn't it? Do you buy a kit or scratch build your own? Use wheels or tracks. Motor select, choose what type of motor, what type of battery you're going to use, and the control method. So let's have a look at the different types of robots. So we have the balancing bot. So this is a 2-wheel robot. It looks very cool. It's a bit painful to keep it upright, and most probably not suitable for most of the challenges. So then we've got the ball balancing robot. So this will be a rather cool design. Once again, a little bit difficult and maybe not suitable for some of the challenges. It'd be great fun though. 2-wheel drag caster type robot. This is the most common kit that you would find. It'll be good for a lot of the challenges, for the maze, maybe this inline speed challenge, and with some of the other ones. The part of the design that will let it down is the back end has got the small little caster over the obstacle course that could actually catch up and catch on side things. So maybe not. Could convert to an RC car. Have a nice fast robot, got a good platform to start from. Only thing that maybe with this is that, and normally the turning circles on them are quite poor. But you've got a good start base. So this is one of my favourite designs. It's a 4-wheel direct drive robot. This one's a very simple one, and I have got here, which if we can pass it around, people can have a look at. So if you can pass that around, Billy. So each of the motors or the wheels on here are directly driven. It's got a really simple chassis, and as you can see, it's quite rapid. Okay. And then we've got a 6-wheel robot. As I said earlier, Revenge is a 6-wheel robot. So the 6-wheel robot's got lots of advantages. It's got lots of torque and grip, and it's very similar for when it's going over rough terrain. It's able to cope and pretty much like a tank trap. Tank traps are good. They've got plenty of grip and things like this. One of the problems with a tank trap is that you need to install them really well, because there's a slight bit of misalignment, or they're not tense enough, they will jump. The tracks will come off. And then I actually like this one, the walking robot. So this one's available as a kit from somewhere. I can't remember where I stole the picture from. Oh, there, I stole the picture from there. A fun robot, whether it be good on the obstacle course and stuff like that, I don't know. I wouldn't suggest that. So, and also some of the other things, you've got the omnidirectional type robot, so These robots can move in any direction. Very good for High Noon. The winner of High Noon last year was Tom Zonin's Triangular, which is an excellent example of a directional robot. And you've got the other variation, the Caffeine wheel robot, which once again can move in any direction. So once you decide on the type of robot that you need to choose what Raspberry Pi that you're going to put into it. Well, there's that many different Raspberry Pis. So basically anything previous of the faulty head I'll dismiss unless you've got one that's kicking about and you want to use that. The newer models thing. So I narrow it down to two choices: the Pi Zero or the Pi 3. The Pi Zero, I really like the Pi Zero. It's a great board for makers and making robots. It has lots of advantages. It doesn't use a lot of power, and it's small, so you can build it into something very small. It has the camera on now, so you can use it for computer CV stuff. And then the Pi 3. The Pi 3 is the most powerful one. It's the most memory. The power consumption is about double or more. But it does have Bluetooth and Wi-Fi built in, and it's got 4 cores rather than a single core. So if you're running multi-threaded software, it could be a better choice for you. So, next big question: do I put wheels and tracks on? So, as I said before, the choice between wheels and tracks. 9 out of 10 times, the same wheels are going to be faster than using tracks. They're not as grippy and maybe not as manoeuvrable as a tracked vehicle, because a tracked vehicle will turn on the spot. And we have got a couple more that can pass around to look at. So on most of my designs, I always go for wheels for the simple life. So the chassis. The chassis is the most important thing of your robot. It actually holds everything together. So you need to choose what do you build it out of. They're saying, do you choose a kit and use that as a base, or do you scratch build something? I always normally scratch build my robots because I have access to the local makerspace in Cambridge. The freedom of scratch building a robot is that you're able to choose everything about that robot, and if you decide that you need to change the motors, build a bit more space, you can change and adjust it. So the first thing to do is to get the motors, the motor driver and the battery, and have those fitted onto the thing, and of course the Raspberry Pi. This would determine every way that your robot runs and works. And once you've done that, you need to test it. Go out and drive it. The biggest thing that I can say for that, I think that actually helped me to win Pi Wars last year, was that I drove it for 2 or 3 hours every week at least, if not 6 or 7. And I also gave it to 200 school kids to test, and they didn't break it. So as I say, all I can say is really just go out there and drive and use it. So motors, big meaty motors. It was a phrase that I had to get in. So we've got different motor types. So you've got the brushless motor. Brushless motors are the more modern type of motor. They've got no brushes to wear out. They can have more torque, which equals more power, and better control, unless it's one of Rob's robots. And you get really good power to size ratio on them. They're quite incredible. They can be a little bit less rugged. They can be complex and expensive controls to control them, and they cost a little bit more than a DC motor. So at the moment, they're sort of like the top end of the type of robot that if you were building, you'd use that. Then you've got the traditional brush motors. They have high torque. All the torque is available when you actually first power that motor up, which is really useful to get your robot moving and over obstacles and everything else. They've got fairly simple control circuits, and they can be very cheap or very expensive. So they actually have a shorter operating life than a brushless motor because they've got the brushes that can wear out. And also they're not normally as powerful as a brushless motor. So, and then you've got the stepper motor, so it's a sensor picture of the brushless one. There's a big meaty motor, and you've got the stepper motor. So this is one of the small, cheap stepper motors that you see in kits, which I find they're nice and precise. You can make a chassis that will drive a robot along thing. They're quite slow. And they're very good for technical challenges, so something like a 3-point turn or anything that you need precision, I would suggest a stepper. If competition is not that way, then you're better off with either a brushless or a brushed motor. So what the markings on the thing, this is quite important. So RPM, that's how fast the motor turns. So, and when you're looking at RPM figures, you want a higher figure than a lower one if you're looking for speed. The lower the figure, the more torque you will get from the motor. You also need to know what rating the voltage is for, so whether you need to use a 12 volt, 6 volt supply, and whether it's a DC or an AC motor. 9 out of 10 times the same, once again, we're going to be using a DC motor. And then another figure that sometimes you see on it is a ratio, and it's actually the opposite way of RPM. So the lower the ratio, the faster the motor be, and the less torque it will have. So another thing you need to know about motors is their stall current. So this is me trying to demonstrate the stall current. So it's running normally, so it's about 0.1 amps. When the motor stalls, can you see the current? So that's the bottom reading, how it increases. Let me run that again. So if you look at it first when it's running, you can see the figure goes up to almost over an amp, nearly 2 amps. So that was nearly 3 amps on a simple stall of the thing. If your motor control is not able to handle that current, the thing you will release the magic smoke, and maybe even go on fire. So motor control, so max peak current. This is how much you can power you can put through the controller. Driving voltage is the voltage that you drive the motors at. So if you've got a 12 volt motor, you can run it on a controller that's rated less than 12 volts, but you won't be able to drive at the full capacity of the motor. So you need to balance that as well. You also got the drive current, how much current the driver can actually handle. So if you've got a 2 amp motor that's when it's running constantly, you need to have a controller that's 2 amps. And then you've got the logic voltage and current. These are the things that the outputs need to be able to supply from your Raspberry Pi, or if you're using an Arduino to control your robot. To actually be able to control the driver chip. So, and you will normally find this information either in the spec of the driver or the driver chip. So here's the common drivers. This is the cheap Chinese one that you find. I don't like this controller, and there's one reason that I don't like it. Can you see the big horrible heatsink? That's the black thing on there. That's the driver chip. The only reason that you have a big heatsink like that is because you've got to get rid of heat. And if it's getting rid of heat, that's wasted power that's not going into your motor. They have got one good advantage about these. They cost about £2.50 off eBay. So if you're driving the yellow cheap motors, so they're maybe an acceptable controller to use. So then if you do your first experiment and things like this, they are rated up to a couple of amps on most of them. Which is fine. There's also the possibility that they also, and some of them depending on sometimes they've got a diode in and they lose sort of like nearly 1.5 volts being actually outputted to the motor as well. So not my favourite. So next up, this is an 8-through controller. This little thing you can see, it's got no heatsink on it. This is actually capable of doing controlling up to about 3 amps and the thing. It's about the size of a postage stamp. The only disadvantage with it is only a single channel rather than dual channel, so you need two of them for you to control a robot. Next up is one of my favourite robot drivers, it's the Explorer Fat and Explorer Hat Pro. You need the Pro because I think it's got the motor drivers, whereas the normal Explorer hasn't. This makes a great little thing. It's on some of my robots. Does it get out? No. That's okay, don't worry. Not important. So the thing over these is a great choice. The only thing with these motors is that they can't actually drive a great current all the time. So you need to use them to think. So the robots passing around, you see that they've got the really tiny robots. Motors. They're ideal for driving these, and they will drive the Chinese yellow motors as well, I believe. Next we got the Python Zero. This is a great one, I like this. So I almost wish that I designed this one myself. It's capable of driving two motors, there's dual channel, has lots of inputs and outputs for other sensors and other functions as well of your robot. This is a great thing. It's got a nice library to it as well, and Gareth was here today as well. But the next one is the Python Zero. This is actually my favourite controller, but I'm a little bit biased about this one because I actually did help to design it. So this is a 4-channel controller, so you can drive 4 motors independently. And this thing does have some sensor outputs. It also runs on I2C, so you can either use it with a zero or a conventional thing. And for using larger batch motors, you've got the Playboy reverse. This takes the capable of driving some of the larger motors, and that is another good choice. So, batteries, or how to make your life interesting in all the wrong ways. So, rule 0, don't be on fire. Read the safety about batteries, especially if you're using LiPos. They can have a nasty habit of catching fire. And it's slippery, and you can remember that at school, the bit that you used to put into the Bunsen burner and it go white, and then you drop it in water and it didn't go out. Not good job. So there's 2 different types of LiPo batteries. The one on the left is the one that's used by model craft drones and when you're building serious robots. Has no safety circuits. You need to make sure that you provide a fuse for it. They're saying this is the type that you see that goes up in smoke. They're saying if it's pierced, damaged, starts swelling, dispose of it sensibly. Things like this. You also need to monitor it. So you can see on this that it's only got the on the back got the little display on it. So this is monitoring the cells. It's saying if you run these below 3 volts, you would damage the battery. You want to get on so let's pass the route. Next we've got the next type, which is the LiPo. This one actually has a safety circuit built in, so it's harder to damage it. They're less likely to catch up to fire and smoke. But once again, read the things, make sure you're charging it properly, use appropriate charging method to do it. I can't emphasise that you need to be careful and safe with these. So there's 3. Well, there's, if you go onto the wiki page at the bottom, you see so many different battery types on there that you think. But the main 3 types that we've most probably come across that are rechargeable are the LiPo. So just a little bit about those. You've got NiCad batteries, or the hydride ones. Basically, they're basically the same. The nickel hydride batteries don't have so much of a memory effect. So. And there's they've brought out modern ones now that don't actually discharge over, so they're a good choice. They've also got can have quite high resistance to them, so they're less likely to go up in smoke. And then you've got the traditional old lead acid battery. This has been about for over 100 years. It's reliable. It's got one disadvantage, that it's really heavy. So if you actually do choose to use it into your robot, it will have an effect on that. The other types of batteries are lighter. I think they're also more power dense as well, so you get more energy out of the size thing. So once again, when you're using the batteries, make sure that you've got them fused, that they're wired in correctly, and that you're charging them as the manufacturer's thing is saying it's an important thing to think. So next thing to consider is control method. How are you going to control your robot? Are you going to control it over Wi-Fi, Bluetooth, have its own controller, use a keyboard or use an app? Well, I always prefer to use a controller, and my favourite ones, these ones, the Afterglow ones. If you want to know about these, come and see us after the talk. They're less hassle to set up than a PS3 Bluetooth controller, which can be bang your head up against a brick wall and eventually it will work. Controlling that, it's got to talk over to your robot, either over Wi-Fi or Bluetooth, and it may be something else in the way of it. You can have connection issues with it, and it also means that if you can't find the appropriate app, you're going to have to write your own one. And sometimes they're not as responsive or controllable as one of the gamepads. And then you've got the keyboard, which is basically a little bit more reliable for connection, but you don't have variable speed on them. You have to press 2 buttons to raise and lower the speed. It's not as intuitive as control. Basically, I'm saying that is saying if you want a good control method, go and buy one of these. So just to emphasise, when you build your robot, you need to drive it. Drive it as often as possible. Get used to how it handles. Learn to love your robot. So, user interface. When something like Paywalls, you need an easy way of being able to choose the different scripts that you're using. If you have to get SH here, intern, fire up putty, or any other thing that you use it, there's chances for errors and mistakes to be made. And especially sort of in the event it's saying, if you can imagine there's 30 or 60 robots in the same area, all of them using Bluetooth, all of them using Wi-Fi, it could be a nightmare. So I actually like to put a display on last year's robot, and it was a touch display and that worked really well. It was a simple interface. I just had to press the correct one and fingers crossed it worked. So, but you could use LEDs, an LED, so if it's in red it's in manual mode, if it's in blue it's in line following mode and so forth. So, and use the extra buttons on your controller to select things. And the most important thing about building a thing is keep it simple. If you add complications to things, one of that step, every time you add an additional step, something could possibly go wrong. So I'm just going to quickly skip over some of the different types of sensors. So for certain challenges, you're going to need sensors. So this year's competition, distance sensors, really important for the main solving. And it's basically 3 types. So you've got the sonic type, which I should have grabbed a picture for it. It's the one that looks like a couple of bug eyes. They're good sensors, they're cheap, which is their main thing. They're very simple to read. Their accuracy is not bad. The problem with them being is that they actually have quite a large, wide spread area of detection. So if you have, for example, if you've got a corner, it actually may read the corner and there'll be a gap beside it, and it won't tell you there's a gap there. Yeah, no problem. Let's get towards the end. So you've got 2 other types of infrared ones. So you've got the an infrared sensor. It's very point to point, a small narrow beam, and more reliable and accurate in distance. And then you've got the new type, which is the time of flight sensor, which is basically it's an IR sensor, but it actually pulses the beam, so it can count how long it takes for the return pulse to come back. They're basically more accurate and more reliable than a conventional IR sensor. So next thing is you've got wheel encoders, motor encoders. This is so you can tell how far your motor or your wheel has turned. may be useful for, say, the second stage of the map, so of the maze that you've gone round. You've worked out where the walls are and you're able to go around a little bit faster because you know that after 10 clicks you've got the next bend to go on. Line following sensors. There's basically an array of receivers and sensors. They tell you where the position of the line is, and quite important for the line following event. The next one you could use a camera. So a camera can be used for computer vision, it could either be used for the line following or the maze solving. I'd like to see a camera being used for the maze solving, that would be fun. For IMU is a type of device that is able to tell you basically which way your robot's facing, whether it's upside down, and which way it's north, so it can find its way home. So, and I keep on getting asked this question: what's the Arduino for? Arduino is a small, dedicated processor board. It's capable of, and it works in real time. Unlike most of the operating systems for the Raspberry Pi, which they'll be doing a task, and then all of a sudden it decides it's going to wander off and do something totally different while you want the precise timing. If you've got mission critical stuff that you want to know precisely the time of it, they're really useful for that. And you can also use them because they're normally built-in analog to digital conversion, so they work with some of the other types of sensors better as well. So this is the list of software that I use. All of it, apart from PyCharm Pro, is free. I use this for either programming, talking to, getting code on and off the Raspberry Pi. The reason I like PyCharm is that I'm dyslexic. I have the spelling age of an 80-year-old, and I'm quite proud of having the spelling age of an 80-year-old. It means I'm kind of very creative in my spelling. PyCharm will connect to your Raspberry Pi, download the libraries that you've got onto it, and it will do auto-completion. And you can also and it will also do all the jobs of FireZilla and GitHub, all in the same interface as well. So, programming, coding, steal it. There's lots and lots of code out there. There's good sites on the Fortronics website, on the Pieboard website, and there's people give away the code out on GitHub. It's saying don't reinvent the wheel unless you need to. It's saying it's the favourite thing of I know programmers is that they like to reinvent the wheel when they don't need to. You will find lots of libraries out there that will do most of the tasks that you want to. But as I say, it's literally standing on the shoulder of giants. It's saying I'm a 47-year-old script kiddie. I'm not the world's best programmer. Most of my code was based on other people's code. So I've got a nice fancy touch interface. That was taken from an internet radio example code. So when you also want to reuse your code, create your own libraries. If you've got a function for stopping the motors and it saves you 2 lines of code, create a library for it. Or not a library, create a function. Also, I would suggest joining PyWars. We've set up an unofficial forum for PyWars this year. If you search Google groups for PyWars, you should find us. And there's lots of knowledgeable people on there. Can help with building and any technical issues that you have with your robot, and you may even get a sensible answer out of us. So the most important thing, drive your robot. So that's me done. Is there any questions, or do you think we've got about a minute to go?
Any questions?
Can you make your slides available on your website?
Yeah, so
I see people are making notes and.
Yeah, I will post up a link to the thing, and I'll pass it on to Tim and Mike as well. So as I say, I'm here for the rest of the day. So over on the micro pointer, which we got a prize to win the robot. So please come along and have a go at that. Gareth Fortronics is kindly donated the robot for them. Hi.
So the first slide you said is 198 days to go, I think. To
Yeah.
Wars. How many days do you think it took for you to do Revenge there?
Okay. I built Revenge first chassis in a weekend. It was actually bolted together, up and running by the end of the weekend.
You're experienced in laser cutting, aren't you?
Yeah, I have advantage to access to a laser cut and stuff like that, so I already know.
And then integrating everything and creating doing the autonomous.
That took the rest of the year. Because I was spending 6 or 7 hours a week driving when I should have been coding and programming. No, the driving's the most important thing. Most of the things I'm making line for and things like this, that's normally maybe an evening or a weekend to nail down. There's plenty of examples out there to follow and actually integrate into your own thing. So it's the thing. I actually finished the design of Revenge actually on the Friday night before the event, because I actually recut the chassis and put the V drive in there because I was an idiot. But yeah, it's literally just making sure that you've got plenty of time. Start early. You may go through a couple of revisions of your design, but if you give yourself plenty of that, the last thing you don't want to be coding on the last evening before the thing. Set yourself a deadline. Go out there, drive it, test it, and things like this. So what we and so I remember the local Hackspace, Makespace in CamJam, Makespace. We're hoping that between now and Pi Wars to hold a couple of well, not events, meetups, so people can come along and hopefully someone discuss, show robots, and we might even try to make some of the courses so people can actually have a bit of a practice as well. So, but I will post details and things like this. So, it's the. Yeah, tyres can have effect. So, depending on what you think. So, it's just the same as if you was driving, say, like a 4x4 car. So, slicks will give you more grip and better for the site, maybe the speed challenge. Normally tyres will be better over the obstacle courses, and the actual size of the wheel will actually have an effect as well of the acceleration and the top speed of your robot as well.
Well, we'll have to leave it there. Thank you very much, Brian.
That's okay.